Hello guys, welcome to another video. In this video, we are going to discuss about the topic earth pressure theory. So, if you see the first question, they have asked us surcharge loading required to be placed on the horizontal backfill of a smooth retaining wall so as to completely eliminate tensile crack. So, keep this as a smooth retaining wall. Okay, and this will be a backfill where this will be a ground level, right? So, they are asking the value of surcharge, which is Q, that to be placed on the horizontal backfill. Okay, sorry, they're placing the surcharge value Q on the horizontal backfill of the smooth retaining wall so as to completely eliminate tensile crack. So, if you see the stress distribution diagram of this particular retaining wall, it will be like, sorry, so it will be somewhere around like this, where the pressure at the top layer. So let us consider the height of the retaining wall as H. Okay. Pressure at the top layer, active pressure at the top layer PA will be equal to Ka gamma H minus 2C root Ka. So at top layer H will be equal to 0, which is PA will be equal to minus 2C root Ka. 2C root Ka. So this zone is nothing but tension zone. So at the top layer, this zone is nothing but tension zone, and the depth of this zone will be equal to H or Z. You can name it as something. Okay. So if we extend Z to the next point, so here also we will be getting 2C root Ka, which is the active earth pressure till Z at compression zone. So this one is the compression zone. Okay. So at the bottom layer, it is nothing but Ka gamma H minus 2C root Ka. Okay. So now they have asked us to find out the value of horizontal backfill surcharge loading. So value of surcharge loading required to completely eliminate tensile crack. So we have to eliminate this tension zone. We have to completely eliminate this tension zone. So for this, that the tension zone, the active earth pressure it is minus 2C Ka. So we have to eliminate 2C Ka, which is at the tension zone. The active earth pressure should be equal to 0. So therefore, Pa should be equal to 0. But at the top layer, the value of Pa, which is Ka gamma H is nothing but Q. Okay, which is the surcharge loading minus 2C root Ka. So if the value of Pa should be 0, then we have to consider, then we can take Kaq minus 2C root Ka. From this, we can find out the value of Q, which will make the active earth pressure at the top layer, which is 0, which is useful in help to help the elimination of tension crack. Okay. So from this, Kaq will be equal to 2C root Ka. Therefore, Q will be equal to 2C by root Ka. Option D is the right answer. In this question, they have given that a 6-meter high retaining wall having a smooth vertical backface retains a layered horizontal backfill. So the top 3-meter thick layer of the backfill is sand having an internal friction y is equal to 30 degrees, while the bottom 3-meter thick layer is clay and it is having a cohesion. Okay, so they have given the unit weight of both sand and clay as 18 kilonewton per meter cube, and they have asked us to find out the total active earth pressure per unit length of the wall. Okay, so we'll draw the wall first. So this is the retaining wall where this one is 3 meter and the remaining 3 meter. Okay, right. So this, sorry. So this will be the backfill, and this one is sand layer. This will be clay layer. This will be ground level. Okay. So sand layer is having an angle of internal friction pi equal to 30 degree. The cohesion of sand will be 0 and the unit weight will be 18 kilonewton per meter cube. So the angle of internal friction for the clay is 0. Cohesion they are given as 20 kilopascal and unit weight is 18 kilonewton per meter cube. Okay, right. If you draw the stress distribution diagram for this retaining wall, it will be something like this. Okay, if you draw the stress distribution diagram, it will be something like this, where this portion, which is, we'll name this one as A, this one will be B, and this one will be C. So top layer will be PA, which is nothing but 0. So at the middle of sand and clay layer, it is PB. It is the pressure distribution for the bottom layer of sand. And this one will be PB dash, which is the pressure distribution at top layer of clay. Because pressure distribution at the bottom layer of sand will not be, may or may not be equal to the pressure distribution of bottom layer of clay. It is always not equal to the pressure distribution of top layer of clay. When the pressure is distributing from sand, clay will have some resistance. So we will calculate the pressure distribution at the top layer of the clay. And PC will be pressure distribution at the bottom layer of the clay, which is nothing but Ka gamma H minus 2C root Ka. So this one will also be given by pressure distribution at B. B dash will be given by Ka gamma H minus 2C root Ka. Okay. So we will calculate all these values and we will consider for sand as Ka1 and for clay it is Ka2. Okay. So we'll calculate Ka1. Ka1 will be 1 minus sine pi divided by 1 plus sine pi. 1 minus sine 30, 1 plus sine 30. So Ka1 will be equal to 1 by 3. Okay. So pressure distribution at sand, at the bottom of the sand, Pb will be equal to Ka gamma H, which is nothing but 1 by 3 into 18 into H, which is 3, which is 18 kilonewton per meter cube. Pressure distribution at the top layer of clay, Pb dash will be equal to K. So see, this one we will take it as Ka1. Okay. Ka2 gamma H minus 2C root Ka2. Because for the clay layer, the value of Ka is 1. Okay. 1 into gamma 18 into H, that is nothing but 3 minus 2C into root 1. So with this we get the value of Pb dash will be 14 kilonewton per meter cube. Okay. So we'll calculate the value of Pc, which is nothing but Ka2 gamma H minus 2C root Ka2. So at C for the total depth. So at C it will be equal to 1 into 18 into 6 minus 2 into 20 into root 1, which gives 68 kilonewton per meter cube. Okay, so PB will be 18, PB dash will be 14, and PC will be 68. So to find out the total active pressure per unit length of this wall, we need to calculate the area of this portion. We need to calculate the area of this whole portion. So area of this whole portion will be equal to, so total active pressure, total active earth pressure per unit length of retaining wall. So which is PA, which is equal to area of top layer half into base, which is 18. You should not take it as 14, you should take it as 18. Okay, into 3, because this is the total pressure developed in sand layer. Okay, plus if you see the next one, if you see this second portion, it will be looking like a trapezium. Okay, so we should take the formula of trapezium. So which is nothing but half into 68 plus 14 into 3, where we will get the pressure distribution as 150 kilonewton per meter. Will not get 150 kilonewton per meter square, because the value of PB, sorry, yes, the value of PB is meter square. Sorry, PB, PA, and PC. PB dash will be also equal to meter square. Yes. So option A is the right answer. In this question, they have asked that a vertical cut is to be made in a soil mass having cohesion. They have given the angle of internal friction, unit weight. Also, they have given the active earth pressure and passive earth pressure. They have asked us to find out the maximum depth of unsupported excavation. So if you see the pressure distribution diagram of a retaining wall, it will be something like, it will be something like this. Okay, so the value of active earth pressure PA will be equal to Ka gamma Z minus 2C root Ka. So this one will be Z, and the value of this one will also be equal to Z. So at the top, the value of Z is equal, when the value of Z is equal to 0, at top we get the pressure distribution as 2C root Ka. Sorry, this one will be equal to Z, where both triangles are similar. Okay, so here also it will be 2C root Ka. Okay, so they have asked us the maximum depth of unsupported excavation, means the zone should not have any tension or compression stress. So the value of active earth pressure should be equal to 0 to find out the depth of unsupported excavation. Okay. So if the value of earth pressure will be equal to 0, then Ka gamma Z will be equal to 2C root Ka. Therefore, Z will be equal to 2C root Ka divided by Ka gamma, which gives you 2C by gamma root Ka. So, which is the value of Z? So, the maximum depth of unsupported excavation, which is nothing but the value of Z from here, which is 2Z. Therefore, 2Z will be equal to 2 into 2C divided by gamma root Ka, which is 4C by gamma root Ka. So 4C by gamma root Ka. Answer D is the right option. In this question, they have given a retaining wall and they have given the lateral active earth pressure acting at the bottom of the wall, which is nothing but 40 kilopascal, 40 kilopascal, which is 40 kilonewton per meter square. Okay. And they have asked us to find out the minimum weight of the wall required to prevent from overturning about its toe. So the weight of the wall will be acting at the center and downwards. Okay. If you draw the stress distribution diagram of this wall, it will be something like this. And the reaction of cohesionless backfill will be acting in the horizontal direction with a depth of h by 3. So the weight of wall uh, required to compensate the overturning moment, which will be nothing but overturning moment should be lesser than or equal to resisting moment. So overturning moment will be happen due to the cohesionless backfill, which is RC into H by 3, which should be lesser than or equal to resisting moment, which is nothing but W into 2, which will be weight of wall into center distance. So we can calculate the value of RCS, the area of this portion. We can calculate the value of RCS, this area of this portion, which is nothing but half into base. They have given the lateral active earth pressure at the bottom of the wall. It is 40 into H by 3, which is 6 by 3. Sorry, half into base into height, right? Into 6 into H by 3, which is 6 by 3, which is lesser than or equal to W into 2. So solving we get 20 this, so 240, which is lesser than or equal to 2W, whereas W will be greater than or equal to 240 divided by 2, which is W will be greater than or equal to 120 kilonewton. So the minimum weight of the wall should be 120 kilonewton. In this question, they have given a soil profile, and if you see the soil profile, they have given that the water table lies 1 meter below the thick sand layer, and there is a seepie soil which lies 5 meter below the sand layer. And they have asked us to find out the active earth pressure at point A. So we need to find out the active earth pressure at point A. So we'll write the solution. At point A, the active earth pressure PA will be nothing but Ka sigma V minus 2C root Ka. So the value of Ka will be Ka is equal to 1 minus sine pi divided by 1 plus sine pi, which is 1 minus sine 24, because we are finding out the active earth pressure at the point A, since the value of pi is 24 divided by 1 plus sine 24. If you calculate, you will get the value as 0.4217. If you see the diagram, they have asked us to find out the active earth pressure. So, in this soil profile, you need to neglect the pressure exerted by the water on the concrete wall, because pressure exerted by water on the concrete wall will come under hydrostatic stress. So, the value of Ka will not be multiplied with gamma W for this problem. Okay. So we'll find out the total vertical stress. So sigma B will be equal to 1 into sigma B. 1 into sigma B plus 4 into, 1 into gamma B plus 4 into gamma sat plus 3 into gamma sat. So to remove the unit weight of water from this, we can find out from the solution, which is gamma dash will be equal to gamma sat minus gamma W, which gives sigma B will be equal to 1 into gamma B plus 4 into gamma sat, 4 into gamma dash plus gamma W plus 3 into gamma dash plus gamma W. So sigma B will be equal to, the value of sigma B, it is 16.5, 16.5 plus 4 gamma dash. 4 gamma dash will be equal to gamma sat minus gamma W. Gamma sat 19 minus 9.81. 19 minus 9.81 plus 4 gamma W plus 3 gamma dash. Gamma dash is nothing but gamma sat minus gamma W. 18.5 minus 9.81. 3 into 18.5 minus 9.81 plus 3 gamma W. So we get sigma V will be equal to 16.5 plus 4 into 19 minus 9.81 plus 3 into 18.5 minus 9.81 plus 4 gamma W plus 3 gamma W. So we'll solve the, let us consider this as equation 2 and this one as equation 1. We'll solve the value in equation 1. So PA will be Ka sigma V. So Ka, which will be multiplied until, Ka will be multiplied until this value. So Ka is equal to 4.4217. 16.5 plus 4 into 19 minus 9.81 plus 3 into 18.5 minus 9.81 plus 7 gamma W minus 2 into C. The value of C will be given by 25. 2 into 25 root Ka. Root Ka will be nothing but root of 0.4217. So if you solve this solution, so if you solve this equation, you will get the solution, that is the value of active earth pressure at point A will be equal to 69.648 kilonewton per meter square. In this question, they have asked us to find out the diagram which closely represents the Rankine's active earth pressure distribution against the wall, where they have given the rigid retaining wall with partially submerged cohesionless backfill with the surcharge. So we'll draw the rigid retaining wall. Rigid retaining wall will be nothing like but this. Sorry. So this will be a rigid retaining wall where it will be where the surcharge Q will be acting, and this will be a height of the rigid retaining wall, and the cohesionless backfill will be having a gamma dash because it is submerged cohesionless backfill. Okay. So which one of the following diagram consists represents the Rankine's active earth pressure? If you see this, this part will be distributed. This part will be carrying a load of KAQ, and this part will be carrying a load of KA gamma dash H. So the pressure distribution of this wall will be given by pressure distribution will be something like this. So option B is the right answer. In this question, they have given that a rigid smooth retaining wall of 7-meter height with vertical backface which retains the saturated clay as backfill, and they have also given the parameters, that is saturated unit weight and cohesion of the backfill. Now they have asked us to find out the difference in the active earth pressure on the wall before and after the occurrence of tension cracks. So if you take the pressure distribution diagram of the vertical wall, it will be something like this. Okay, it will be something like this, where this depth will be a critical depth, and if it extended to this one, it will also be ZC. The total height of the wall will be equal to 7 meters. So at the top, it will be equal to 2C root Ka. The value of active earth pressure at top will be equal to 2C root Ka, and which one is the tension zone, and this one is the compression zone. So this one also will be equal to 2C root Ka, and active earth pressure at the bottom of the wall will be equal to Ka gamma H minus 2C root Ka. Since they have given the saturated unit weight, which means the vertical wall retains saturated clay as backfill, the angle of internal friction will be equal to 0. Therefore, Ka will be equal to 1 minus sine 0 divided by 1 plus sine 0, which is nothing but 1. So the value of Zc will be given by Zc will be equal to 2C by gamma root Ka, which is 2 into 20 divided by gamma, which is nothing but 17.2 root 1, which will be 80 point, sorry, 2C by gamma root Ka, which will be nothing but 2.32 meter. Okay. So the total depth of unsupported excavation, that is, if we eliminate the tension cracks, so we have to neglect this much of height. If we eliminate the tension cracks, we have to neglect this much of height, and this height will be equal to 7 minus 2.64, which is nothing but 7 minus 2.64, which is nothing but 4.36. So at first, we have to find out the C, and also we have to calculate the value of 2C root Ka, because active pressure we have to calculate the value of here, and we have to calculate the value of here also. Okay, so we'll name these points, which is A, this one it is B, and this one it is C, and origin will be O. Okay, so active earth pressure at PA, which is equal to PB, which is nothing but 2C root Ka, which is 40 root 1, that is 40 kilonewton per meter square. Okay. So the value of PC will be equal to Ka gamma H minus 2C root Ka. So 1 into gamma 17.2 into H will be 7 minus 2C root K is nothing but 40, which will give you 80.4 kilonewton per meter square or kilopascal. Okay. Now we can calculate the earth pressure where tension cracks are not considered. Where tension cracks are not considered. So we have to calculate the earth pressure of this zone. Okay. So here the active earth pressure will be 40 and here it will be 80.4. So this is like a trapezium. So we can find out the pressure using the area of the trapezium, which is nothing but Pa is equal to 1 by 2 40 plus 80.4 into 2 point, sorry, see, this height, it is actually 7 minus 4.64. 7 minus 4.64. 7 minus 4.64 will be 2.36. 2.36. Okay. So it is 2.36. So which gives you, we'll calculate 120.4 into 2.36 divided by 2.54, which gives you 142.072 kilonewton per meter square. Now we have to calculate earth pressure. We have to calculate earth pressure where tension cracks are considered. So we can calculate the earth pressure where tension cracks are considered. We can take this diagram. Earth pressure when tension cracks are considered, then the diagram will be nothing but it will look like this, because we are considering till this zone. We are considering till this zone, and the height will be equal to 2.36 plus 2.32. So till here it is 2.36 and this one 2.32, where the height will be given by 4.68. Sorry. This height will be 4.68. Okay. So we have to calculate the value of earth pressure for this zone. So the value of active earth pressure for this zone will be equal to half into area of the triangle, which is nothing but base into height. The value of base is given by 80.4. Half into base 80.4 into height, which is nothing but 4.68. 80.4 into 4.68, which gives you 1, which gives you 188.136 kilonewton per meter square. Now they have asked us to find out the difference between the lateral active forces before and after occurrence of tension cracks. Therefore, difference will be nothing but before tension cracks it is 142.072 and after tension cracks it is 188.136. So if you calculate 142.072 minus 188.136, we will get minus 46.064 kilonewton per meter square.